Well, more than I thought. Okay. Doesn't hurt to see a comparison how things are presented. I saw in this class maybe about a third. I just wanted a rough feel. How he set it up, he has the next section and what he calls it, what the heck is it? Control. Control, the programming term, refers to control of the flow, branching and looping. I broke this off into sections, partly so it's nice bite-sized parts. But then under control, he has defining methods, which was kind of an odd classification. And then under control, he has a little bit of intro to so I broke it out. There's some difference how I present it and have a lot more detail. So right now we're still in what he refers to as control, only partway through. And the main gist of this one is essentially call a spade, it's procedural programming. Although there are no functions in Java, and a function is where you can define basically a function outside of a class. You syntactically can't do that in Java the way you can in Python. What you're going to do with your assignment number 1 is you will define, you're required to do that, basically one class, and that class has multiple methods. You might have something that contains main, at most 2 classes, but you don't have multiple classes beyond that. And you're just calling methods as if they were functions. And you do that by defining those methods with static. In essence, that's procedural programming. However, he also talks about that keyword static in conjunction when you define an attribute. Boy, that opened up a bit of a can of worms, just like with the for each opened up the can of worms with the array. So I also, even before the next section, intro to OO, I have to, in order to really understand what it means when you have a static attribute properly, you really have to understand the class definition. So contrast now details, defining classes, Python, Java. So we have the Python approach, we have the Java approach. Not too much difference here. The constructor, for sure, it has to match the name. So there's the annotate. Exactly as is. Case sensitive. The constructor over here, by default, it's the init underscore preferencing it. But I've color coded this, say the constructor, the constructor. Now with this self, the Python self, it crammed it down your throat. Really don't like that part of Python. That's approximately largely equal to this. So for instance, if I want to access name, if I decided to use the equivalent of self, you don't have to. This dot name look like that. It's not mandatory. It's not a stupid parameter because this is rather confusing to beginners at first. When I call a init, I have to pass one parameter, only one parameter, but there's 2 here. Very confusing the way he set this up. As there's a need, I'll talk about that self-reference essentially, but I'm trying to keep it simple. Even when I get to intro to OO, I'm trying to keep it simple. Attributes. Attributes, recall, we have class person. Think about it. Name. Each person can have their own name. We can have 2 people who happen to have the same name, but that's coincidence. Consequently, each person object has to have the ability to track a name. We indicate that it is an attribute for each instance by prefacing it with self in Python. Now, this is another major difference. Over here, this is an attribute. I've color-coded it. You actually don't define it in the constructor. This was really annoying over here with Python. They actually forced it in the constructor. The other languages I've seen, the OO ones don't do it that way. He just did it on his own. It's done this way outside the class. But it's color-coded. That's where you define the attribute. So in both cases, each object will have a name attribute. And we can also define methods. Each method that we define in a Python class has to take at least a self parameter. This one explicitly has to take it. It does exist, but we don't have to explicitly pass it. Also, we have the public private. I said more, as I say here, more on that later. But for now, the rule of thumb, the attributes are private. This is actually common convention, the methods are all public. More explanation on that later. Once we actually, in Python, in main or any other method, once we define the class, then we can instantiate or create an object here, which then calls that. And once we have basically a reference to an object, then we can use that reference to call methods. And you probably should have had a feel for this. We need to, with methods, we have to define it inside the body of class. Inside the body of class, a function is defined here. But another difference is, with a method, we have to call it through an instance. And it makes some sense here. If we have two people, whose name are we dealing with? So we need to say instance name. Whose name are we dealing with in this case? So this is the basics into OO. You need a little bit of this when we talk about static. What you're going to do in the assignment 1. Is there any questions about this so far? Oh, see something that's come up in the chat. No one raised their hand, so I didn't notice it at first. Where are they? I don't know what you mean by where are they. The literal question someone asks is where are they? Maybe ask this or something. I'm not sure. So question literally says where are they, but what's they? Context. Okay. Is there any questions about the basic structure of defining class? What are the parts in Java? So this should help you use this is a bridging gap for this, a learning gap. Now, if there's no questions, I'm going to erase this. I'm going to add an extra little thing here I need to add. Where's the erase? How do I get rid of all these ones? Oh, there it is, trash. They're all drawings. There. Now, an extra thing I want to mention is with the assignment 1. You actually don't do it this way. What you need to do is you should say assignment 1 only. In other words, what you'll have to do, well, except for the constructor, but you really, I don't think you need a constructor, is you have to include that keyword static in front of the method name the way you did with main. And the significance of it will come up in a moment. Or come up in the next few lessons right there. And every method has to have that static. That's actually not OO, but he made the decision. There's pluses and minuses to requiring the first assignment being static. I actually did that once many, many years ago when I taught 233, but there's also drawbacks. And my opinion was that the drawbacks aren't worth the benefits. The benefit is it's a bridging gap to help you learn Java. And that's why I actually had it in here initially, years ago. So this is where static will come into play. But to really understand the static in conjunction with when you put static in an attribute, I really actually have to give you a basic OO like this. You got a minute left, so what I actually have to do is this. Now with these examples, I'll show you the file structure. You know, proper style-wise and to work with IntelliJ, I had to do this. So my structure to work with, to organize this is procedural programming. This section notes it's procedural programming is its own folder. As I said with IntelliJ, open that folder. Don't open individual ones normally. But now what we're going to have is with this procedural programming, say example 1, it's its own folder because it consists, oh, that one doesn't. That's just showing the syntax. I'm sorry. This one is just showing the syntax of a Java class and a Python class, so vice versa. But the other ones is showing you, what if you have more classes? Each one is its own file. So person.java is its own file, and it matches it this. And multi-class is in a file. Now the problem is, with this is good style. Each class is its own file, I mentioned that. Problem is IntelliJ then, if you try and import, oh, this is something. This one, the way you did previously, that folder, you're going to have problems because example 2 has a person. I do that, it's the same class because I'm trying to make it easy. So you see person class once, you don't have to see it again. Example 3 also has class person. It's going to have a conflict here. So what you do is you open each one of these separate subfolders into IntelliJ, and it's a separate project. In other words, a separate piece of software. That's an extra little part. And what I'm referring to here is they're included in their own separate folders. So this example has its own folder and its own programs here. And we'll get to the details of that, the trace of it later. But I needed to explain why I have this file structure. So I do have a zip of this, should have a zip of all this. And then it'll create that file structure to solve. A review of the basics of creating a Java program. To properly demonstrate, to describe the reasons behind things with static and procedural programming, I actually have to do a little bit of OO. This example, the learning objective, is unlike the previous one where it was all in one file. If we have multiple classes, and you should, recall what I was saying, is your program should be in separate classes. That's the way it actually should. Each class should be its own separate file. So unlike what you did with 231, there's a Python class here, there's Java class here. With 231, you could define it all in one file here. And also you did some things that you really shouldn't be doing, mix and matching between OO, object orientation, and procedural. These are procedures, not part of a function. And one reason why you could do this is because even if you had all your files for one program in the same folder, Python really implements it all in a very poor fashion. You actually have to import your own code, even though it's in the same location. What you've seen up to this point is a Java equivalent where it is just one file again. The file name should match a class name. Of course, there's no .java here. Now what you're looking at with this last example, one of the learning objectives is splitting it. Now I'm splitting this into separate subfolders. I used to just have, for that week's topic, I put in its folder. I need to have separate subfolders for each of the examples because each example now has multiple files, and now there's the extra overhead here of adding it to IntelliJ. And then when you open, as I said, you open the folder with just one example at a time. And the reason I had to do that, this was a bit of an IntelliJ issue, is that I have class person. It's the same. To keep things easier in terms of learning, it's basically the same class definition. So you have to relearn a new one. Fine, but there's other new learning lessons. I have also, if you recall, class person with example 1. It didn't have a main, so you couldn't execute, but it's just illustrating the parts. Same definition. IntelliJ has a great problem. If I try and import them into one, they're all in one folder because it counts as one project, one software program. Now you have a naming conflict between this person and the one in example 2. And I'll go back to example number 1, source code. So this is the starting execution point of the program because it contains main. Notice there's no need to import things. If you have in Java, if you have all your .java files in the same directory, IntelliJ, it'll be okay. If you build this in IntelliJ, you say project and you say location, it will then have your code in the same location here. Now the .class files, these are the ones that I created when I ran it through the command line. I think they're actually in the IntelliJ created ones in some subfolder production. Yeah, it's a deep folder. So you just, if you compile through a command line in IntelliJ, you might have a different version you can compile at different times. And there's no need for an import. However, there may be an additional little thing you'll have to do. Did I get to it here yet? Here. You might have to tell the operating system, Unix, Linux doesn't do this by default. And Windows, I'm not sure because I've actually configured this a long time ago. You might have to set first you have to set the path to tell it where Java is installed. And then you might have to set the class path to indicate that dot right here, if you enlarge it, it's indicating the current working directory. The current working directory means that if I am running this program in the location here, not all operating systems by default will look in that location for your class files. So you might have to configure the class path to include dot the current working directory. I can't remember that off the top of my head because I set this a long time ago. And in order for me to test it, I'd actually have to set it, reboot my machine, but I've got multiple accounts typically running and multiple things running, so it's really disruptive. But that's something to be aware of. If you have your code in the same location, simple little test program, it doesn't seem to work. Again, IntelliJ, barring its quirks, should be okay. IntelliJ, you have to have, what was it? I put an extra little set of notes for this. Where is the damn IntelliJ? It's hidden by all these Zoom windows. Okay. See it. I'll screen share for a sec. There it is. Okay, screen share. With IntelliJ, just make sure that when you create your class has to be created. Select there's the heck is it new, and then class. Project, where the hell is it? Maybe it's right click here. New HTML file. I can't remember that option is off the top of my head. To create that new class, you have to just click on this folder. And it doesn't idiot proof it. You can be in some other location and then let's say it won't compile. Now, that's the logistics of it. The learning lesson with this one, the recap is, as we create an object, we call the constructor, pass to it this string. And actually, I'll pull up class. Now I'll pull it up. Pull up here. It's right here. I'm a fool. We have this attribute defined in this following fashion. If we define it this way, as is, it means that each instance of the class will have that name attribute, as it should in this example. It's like defining an attribute, an object's attribute in Python. Say name. Whose name do we display? It depends on, is it this reference or this reference? We're calling Sifu's, and Sifu's is Yipman. We create another object, the student one, and it has its own name. And the name is Bruce Lee, so we call say name. We call the student's say name method, which accesses Bruce Lee's method. So the key point besides the logistics is every time that you define an attribute this way, each object will have that attribute or attributes. And I picked this example rather. The classic approach for defining classes is class who, but that's kind of abstract. This is more concrete. You have something where it's intuitive. Each individual has their name, other attributes like age, height, weight. You can coincidentally, how probable it is, I don't know, but it's not impossible. Two different people, same name, same height, same weight, but it's improbable. And you do have to have that ability to track it. That's the basics of all. More details that I kind of hand-waved because you had so much to learn before. I didn't want to get into details. I said just template mimic the examples I had. When you define a method, you have to have that you almost certainly should have that public keyword. It's not required by the syntax, but there's a good reason for putting up methods. Attributes are private. That's the stylistic requirement. Methods are public, with exceptions. It'll compile if you leave it out, but it's not a good idea to do so. We'll get more into the public private in a bit. We have, so public access, the method name. The return type. When you create a variable, recall, in Java, unlike Python, you're creating a memory location, but you have to specify what type of information will be stored there. In a similar fashion, when you define, oh, man, I've left this off. copy paste it, but that got deleted. In a similar fashion, we define a method. It has to have a type. If you're not returning anything, there's no return, or there's a return where it's not returning any explicit type, this returns nothing, then it's void. Void is the absence of any type. There's an exception over here I haven't gotten to. Oh, someone's waiting. I thought that was a hand raised. Okay. And if you mix and match, there'll be some problems. If you say it returns a void and then you have it return something else, an integer, you're going to get a compile error. It's very strict on types. The exception to this is a constructor. You never, in all the old languages that I have seen thus far, you never specify a return type for the constructor. Why is that? Any thoughts about that? The constructor by default, let's have some code hanging just to quickly bang up some code. Person, a person. That can contain the address of a person object. It currently doesn't. When we create a person object with the new keyword, that's when we actually create something dynamically. And dynamically, you don't attach a value judgment. It just means that we're creating it on the fly. Previously, I didn't create it. It's not mandatory. And now I can create one whenever I want to. At this point, we're calling the constructor, and that returns the address of the object of this type. Because the constructor is matched to that class, you do not specify the type. That's a convention among the old languages that I've seen. So there is that one exception. It's a given that you have a constructor for class dog. It returns a dog. Actually, the address of a dog would be specific, but it's correct. It's okay to say it's returning a dog. If it's a cat, returns a cat. If it's a person constructor, returns a person. There's some more complexities that come later, but that's building on what we have here. The parameters, this I kind of hand wave, but just to formally put notation, just like Python, we separate each parameter with a comma, but we have to specify the type. P1's type is that, and the name. So the part of the name is basically Python-like. We're basically creating local variables to store what's passed in, and these are names of the locals, but we have, as we create variables, with a strongly typed language like Java, we have to specify the type of location. And if we pass set attributes with different values, the first one isn't a string, then we're going to have a type mismatch, file error. Any questions thus far? And details the constructor name, because it's constructing an object of that class, the constructor name has to match the class name. Automatically called when you create an object, so we call this no return type, and no explicit return necessary either. Another thing, it's built into the definition of what a constructor is. It'll automatically return the address of the object in the class for the particular class. Null, I said it returns an address of that object. Null means it's a non-existent. It doesn't point anywhere. It doesn't refer to an object. But null is not the same as void. If you return null, then that is returning a type. It's potentially containing the address of an object or something like a list. And if you say the function or method returns void and you return null, you get another compile error. They're not one and the same. Method overloading. So you can't see it as clearly as live. There's benefits of live versus in person. But as I use this term method overloading, you might see me just sort of concentrate for a second, because this is very, very close to another term, but it's a different concept, overriding. Until I talk about inheritance, and that's maybe, I estimate 2/3 of the way through. For me, when I teach my schedule, 2/3, 3/4. if I say overriding, like ride, I'm referring to overloading. Overloading. The term basically means just this. You've got a method that has the same name, but they do different things. That could seem confusing. So in essence, it looks like this. Say we've got a method. Make the font smaller so fit this. Advantage of the remote is people don't have trouble seeing smaller fonts unless it's a micro. Say we have a consume method. I just thought of this one on the fly, this example. And we have, so we pass to an integer. It's going to be for a liquid. And it's the milliliters of liquid we're going to consume. Different behavior. It's first, let me finish this one. So the behavior is drink. I don't have to write code for drinking, but whatever drinking entails. If we were overloading, we'd have another version of this method, also called consume. Seems confusing. How do we distinguish it? The parameter list. Book. Some people might use that. You don't necessarily, I didn't call it ingest, but some people say I'm reading that book. We consume the book. I devour the book. They might use that term. The behavior is different for this versus this. You might eat a book if you're really hungry, but you wouldn't drink a book. And we could have one for food. How do we distinguish between this consume and this consume? Everything's identical. What distinguishes it is the parameter list. The parameter list, more details, very specific. No, according to syntax, how overloaded methods are distinguished. Differentiated, distinguished kind of adds a value, doesn't it? Differentiated. It said parameters. There's the type of the type of the parameters. This versus this. There's the number of the parameters. We could have a consume. Copy paste this. A consume, we have a book. And then we have a drink, read book, drink liquid. The number, we have two parameters here. We have one here. If we have another one that's two parameters, then it's the type of the parameters that can distinguish it. Maybe we have a book, and then, I don't know, we have a string for food. In this case, it's a book and an int, we drink. If it's a book and a string, did we eat and read? Now, the third one, in terms of parameters that can distinguish this, is order. Shrink this font a bit. Don't need such big font. I'm not in person. So we could have a version of consume int char versus consume char int. The compiler can tell the difference, but stylistically, it's easy for another programmer to mix the two up. And if we have two completely different behaviors, then you might end up calling the wrong method. It's just like if you have two variables, most languages or all languages can distinguish between case. But a programmer can have problems with upper versus lowercase. So you shouldn't have two variables with basically the same name, only distinguished by case. Okay, so that's overloading. Same method name, the return type is irrelevant. It won't distinguish between two. And it's the parameters that tells the difference between these ones. And the idea is you have different behaviors, different instructions between these. If there's some common instructions, then rather than duplicate it, write another method and basically have the assuming there's some common, some unique instructions, the common methods are implemented in another method, and it's called by each of these ones. And then we have the unique method, just unique method here, just unique method here, and so on. So this is what method overloading is, the mechanics of it. I actually haven't gotten to this part yet, why you want to do it. Is there questions about what method overloading is? So I had to take a bit of time to explain the mechanics of it. There's a good reason for using this tool. Very good reason. Why do it? Class print string. That's the one that has the methods for displaying text output in the fashion you're being taught. There's probably others, but this is a very simple approach. I'll abstract this a bit and exclude irrelevant details. Print. I'll have a general print here, or less important details in terms of this learning lesson. Yes, there's system out, but that's not the key part. I assume you know how to call print. If we pass to an integer, if we did not overload, why do overloading? Why does it exist? Well, what if we didn't do overloading? If it didn't exist, a print, and we'd have to convert it, say, from an integer or a long to a string. If we had one print and there's no way distinguishing another print, in other words, method overloading didn't exist, well, we wouldn't be able to do it this way. Have the same method print and print, one handles ints, one handles strings. Overloading allows us to distinguish these two by the parameters. Well, if this didn't exist, then what would we have to do? We'd have to have a version of print for each one of these types, which would be rather ugly. So say print int, or whatever you choose to call it, print string. Now you have to memorize these details, the exact name for each type, and it's awkward. And you're going to have undoubtedly a fair amount of code that overlaps between these. Your program, your class definition is going to be bloated unnecessarily. So this approach right now is, what if we didn't have no overloading? Yeah, I think a hand raised. And now I haven't quite finished it yet with the overloaded example, but the question was the hand raised, or was it just about to? Oh, maybe it wasn't a hand raised. It was someone coming in the waiting room. Okay, so now it is implemented with overloading. Oops, it's not print in, just print and print ln. All we have to do is know it's that method. And then here, see, we have an overloaded print ln. Depending on which type of parameter we pass to it determines which method that we actually will call. So the programmer who's using your code doesn't have to memorize. Is it print int? Is it print boolean? They just have to know system.out_print and then pass the type to be displayed on screen. There's one example of method overloading, why you'd want to use it. There's another more compelling. This writing methods where you're overloading it, just from my experience, it doesn't mean that this is the way it always works. From my own personal experience, I tend not to overload methods like this, but I find it useful. When do I use overloading? With constructors. You can overload any method, a constructor or non-constructor. But I actually, when I use overloading, and I will use examples, the constructor. So that's example number 3. Now, so I've augmented class person, but IntelliJ would have problems because this one, 3. Example 2 has person.java. It only has one constructor, takes a string as a parameter. Example 3 has the file names the same. And it would confuse the two because it can't treat these as separate programs. The only way it distinguishes programs is by directory folders. And this is one that has multiple constructors. So why would we have constructors like this that take different parameters? Well, think in the case, use the example I had from this morning's class. When we have a client, we're tracking clients, we're a business. And you just use the Walmart case, or it could be some other case, say Walmart. They ask you when you're checking out, sometimes too much, do you want a Walmart card? And some of them, I know they have to ask the management, pushes them, and they get a bonus doing this. But some are very obnoxious about it, keep pressing, say no, they keep getting, come on, buy it, no. But when they actually get someone who signs up for something like this, in order to get you the credit card, there's a bare minimum amount of information that's necessary in order to process the credit application, enough to check that person's credit. So things like the name, contact information. What's optional, be aware of, is social insurance number. You don't have to provide it. If you have a clear credit rating, you have some credit history, good or bad, you don't need it. And if I don't have to provide it in certain cases, I wouldn't give it. If you're new, you have no credit bureau, it's not a good idea to leave it out because then you might get rejected for lack of information. That's optional. Other information like what's it? Birthday. It's name and birthday. Those are the bare minimum ones that they typically use to determine to look up your credit file. The SIN number is also, well, if there's some ambiguity. Okay. There's additional information that the person might not know, things like employer, what credit that they've had, and so on and so forth. Those are ones they can still process, again, depending on the person's credit. Now, think about this. We have a client object, not similar person. There's some cases where we have, if there's bare minimum, then we can't have an empty constructor. There's other cases where we have some information, but not other information. So in other words, when we create an object, we might not be able to access all the fields, or we might not have information about the fields. So we just do a fill in the blank for the ones. This is a very simple example. We just have, okay, if we don't pass in a name, we give it a default name. If we know the name when we create the object, then the name attribute is set to that. And this is where method overloading, watch myself, maybe I don't say the wrong thing. Overloading is useful, really useful, I find, is with constructors. Handles different cases. Which constructor we call basically depends on at runtime. At compile time. When we talk about overriding, that's where difference comes in. We have the default person. We pass no arguments constructor. So parameterless indicates we call this one. I have my own convention is I have these extra tracing questions, debugging type questions. So it shows it helps you follow along which method is being called. The no argument constructor or the constructor that takes a string. I put the angle bracket, say, this is not what we'd have in a real life commercial program, or we'd hide it when the user's running it, maybe under certain modes. But it makes it easier for students as they're tracing, tell the difference. And if you want to modify, say, add a string, then you'll see this one called. In this case, we set the name attribute to this. This case, we do have a name. Well, it's not a great name. That I have a real name is passed because it's a string we call this one. And that I have a real name sets this object's name field to I have a real name. And when we call the say name for the different cases, default person say name, well, displays default person's name, which, as we saw here, is no name. The screen grabs here. On the other hand, we call the non-default person, called say name. We access the non-default person, which is we saw we passed this one. I have a real name and the name field set to that, and that's what appears. So a very simple example, simple in the Walmart example. Some of you asked in 231 for me to go through real life examples, but you don't know what you're asking for. Real life coding projects are hard. They take a long time for professional programmers to get up to speed. It may take a few weeks, a few months, and those guys are experienced. For me to go over it, I could spend a whole semester going over, but it's so complicated, you only have a small grasp of just a part of it. But the main thing is teaching these concepts. I have a small example. These concepts are applied in real life. I try and make it concrete with real life examples. And I color code which version of the constructor, the red or blue one, we're calling. So that's method overloading. Personally, I find that I'm used it the most with the constructors, different versions of the constructor. Ask again any questions. I'm about to go on to a different topic, but I want you to have this base. You have to have a fairly decent base before you can understand this next topic. Okay, back to class person. With class person, I have definition person. I create 3-person objects. What if I wanted to track in certain programs, it's not inconceivable, the number of people objects I have created at various times in the program based on what you have been taught. Don't jump ahead. Someone was keen, they actually jumped to the climax. I said, you're correct, but we have to build to it because you have to see the need for why we need this. How would we track this information, number of objects, based on what you've been taught currently this semester? Hint is you've been taught enough to be able to track this. And if you've got it. Okay. I'll give you a hint. What type of variable would we use to track the number of objects? Or what type? There's more than one type. Which types could we use? Be more specific, first thing. Would we track it with a string? Would we track it with a scanner object? Will we track another type of? Okay, club me over a head hint. I have one person. I can track my fingers. I have 2 people. Hold up another finger. I have 3 people. I get rid of one of the people. I lower a finger. What type of information is being tracked with my fingers? What type of variable? Or what type of variables is this? Okay, finally. Isn't? I assume we meant int. Few people say, okay, typo, int. It's an integer or it could be a long. That's why I said types of variables. Fine. Given it's an integer, how will we track this integer information based on tools you've been taught? How would we track the number of objects? What programming mechanism would we use? Even if you have to go back thinking of Python. Okay, we have an integer. How would we use that integer? The integer type. How would we apply it? You can't just say type, for instance. You can't just obviously type int, whether it's in a Java or Python program. We need a mechanism to store this. We need a variable, for gosh sakes. Not a trick question. That's one way that we can track this. Population size. See, it wasn't a trick question. Okay, with this int pop size, given this, where would we declare it? Okay, there's 2 possibilities. Someone said we can, based on what you've taught, this could actually be part of a class person. Possible. There's another possibility. Intuitively, you think, well, if we're tracking the population of people objects, intuition is it can be an attribute of class person. From what you've been taught now with class person, however, if we make it an attribute from what you've been taught, repeat again, attributes, as I said, means that each person object will have that name attribute, as it should. Each person can have a different name. Now, in this case, population size exists for each person object. Interesting can of worms it starts opening. Which of these objects should track this information? We're building here. Is it Bill? Is it Jim? Is it Nellie? Okay, intuition. Bill. We need to track that we've created an object, so the Bill object for sure has to track it if it's as an attribute. So Bill tracks it. Then we create Jim. We increase Bill's attribute from 1 to 2. We create Nellie, and then Nellie, Bill's attribute increases. Seems to be some intuition here. However, even if Bill is tracking this, so Bill has track this 3 for that attribute. The other ones don't have, if it's just Bill tracking it, it would be set to some default value 0 for these two. Now these ones are kind of useless. It's a waste of space, as it were, a waste of memory. Bill already has it. Why are these guys tracking it? What if we get rid of Bill? I can do it explicitly. Like that, what happens is that object referred to by Bill it's flagged to indicate that it can be garbage collected or cleaned up as needed, because no, Bill no longer refers to it. Now that information about the 3 is gone. So having Bill track it isn't such a good idea. Or if we don't do it explicitly, Bill could be part of a method, a local. And then when we create Bill, if it's a local, even if it wasn't set to null explicitly, once that method ends, the Bill object goes out of scope. It's no longer accessible. So we can't have a particular object track that information. We have it as an attribute. Given it's an attribute, what else can we do to track this information? How else can we keep track of the size? Given the problems. Well, given I said if we have one object track the information, there's problems where that object's gone. Now, oh. Okay, no, attribute for now. Your answer, Manuel, is correct, but I'll build the non-attribute approach in a bit. We're going to have to basically, if we're making an attribute, every object will have to track that information. So we have to update all 3 of these ones. We don't know when we might lose them, for instance. It's too vulnerable. That's a waste. Furthermore, unlike the other one where one tracks it, each time that we create an object, we have to remember to go through and update all these objects. If we get rid of one, then we have to update and decrement all the objects. So now this is leading the case where making it an attribute from what you've been taught, having each instance of a class track it, has a lot of problems. Furthermore, right here, what if we need this information before us saying, so get rid of this stuff here. And this arrow is indicating it. Before we actually create any objects, we still want this information. It's not unreasonable where we ask, what's the size of our population before we created any? The only way we can access this is through an object. We have no objects, can't access it if it's an attribute, the way we've defined this. So what I'm referring to is right the first point here. If we need this information, we cannot access because there's no objects. So creating it, even though intuitively creating it as an attribute to track that information, it isn't going to work. So Emmanuel had a point here. So when I was asking how can we track it, one way is an attribute. There's some intuition, but there's problems with it. The other way Emmanuel had gotten to is, I gave you a hint with this one, I kind of led you towards it. If we have in population size, that looks like a local variable declaration. And that's what Emmanuel said. That's correct here. Quick answer to your question, Emmanuel. Attributes, as you've been taught, stylistically have to be public. Sorry, no, wait. Attributes you've been taught private and for a good reason, but we haven't gotten to it yet. Methods are public. Someone asked about the private public, but we haven't really talked about access permissions. Okay, if we make this a local variable, which method do we actually declare it in? There's scope. Even if we declare it inside of main, that's not global memory, the way you have global memory declared in Python. We call another method, even if it's a method of the same class where main's defined, unless we pass in the parameter, you should know at this point, when we're in this A method, if this is local to main, we can't access it here unless we pass it as a parameter. So the two approaches that you've been taught for tracking this information, one, as a class attribute, as you've been taught, has problems. The major problem that shows up, but there's other ones, is it requires an instance to be able to track it because it's tied to instances, number of instances. If we have no instance, we have a problem. The other way you've been taught for tracking this information is as a local variable, but we could implement it as a local, and declare it main and then pass it to all the other methods. That's extremely awkward. If we need this memory, if we need this information throughout the program, we have to pass it to each and every method manually. Static. Now, this section is static. It says procedural programming. There's two cases when you can use a static keyword. One is with attributes of a class. The second is with methods. You've seen the syntax requirement. Main has to be static for a reason. But we're first talk about the attribute. Static. If you modify an attribute, the keyword static, it means that information isn't tracked with individual objects or by individual objects. We've used instance fields like name, where it means each instance has that information. Most of the time it's appropriate to use an instance field when the information is unique to each object, name, height, weight, social insurance number, and so on. That's an instance field from what you've been taught. I've been pounding home that point. That means that when we create objects, each object will have its name field. Improbable, but we can have three people in the same room unless it's a reunion of, it's a family and we're asking about last name. It's improbable they're all going to have the same name. What we're looking at, well, the flock size, it used to have a sheep example. Okay, we have a flock of people. We have information that's tracked that is independent, not associated with a particular object or a person. It's outside of this. Static means that it's outside of particular instances. So we can track it before we actually create an instance. Static now, it's not the same as the keyword final. In Java, final means that the initial value is the final value. Take note of that. People confuse static and final. Static is for constants. Final is for constants. I think I said that wrong. Static means that that information is associated with the class, not with the instances. I don't know why they couldn't think of a word that maybe you could call it class memory, but it would be kind of awkward. So they called it static memory. It's not exactly the same as a global, because a global is independent of everything except for your program. It's tied to your program. This is tied to class person. We can also have static information. Think about the population size of people, population size of a flock of sheep, population size of fish, population size of bacteria. Each one has its own population size. And the population of the number of people is associated with the person object. Population of sheep is associated with sheep object. So it's still narrowed down to that class, but it's not tied to an instance. Class methods, I'm here for minutes. Similar to class attributes, they're not tied to a particular instance. When would we define, aside from main, define in a static method? Well, intuitively, if we have population size, we have class person. And now we define an attribute that size for population size, it starts off at 0. What we can't do is, oops, static int. Static means it's associated with the class, not instances. What we can't do is if we're main and we have no objects, on objects, no objects. If we made it accessible in a regular method, there can be problems if it's static. There's a problem with it as is. Default. This requires an instance as is. If we have no objects, we might need to be able to determine the size. So a regular method won't cut it. What we have to do is use the keyword static here. Now, in this case, static methods, it's not associated with an instance, so we can call it through the class. Example, contrast. Instance method, scanner class, we create an instance here, and then we call next instance method through that instance. We could potentially have 2 scanner objects. Class math has essentially, class math is full of functionality, code, math operations. Square root operation, you know what it does mathematically. This returns 3. If we had multiple math objects, would one math object square root versus another math object square root do anything different? No, it's the same thing. It takes a square root of volume. Consequently, class math consists of basically just static methods. You don't actually have to instantiate any instances, and you call it through the class. Consequently, this static if we're trying to, intuition, why would we make methods static? One case is if we have static attributes, then we can access that information through the class, not through an instance. We can still access it. That's how that's one example of why you want to write a method statically. Now your assignment number 1, heard that one's out, I didn't have time to check. Whatever you call it, you should have a better name than this. I think it's connect 4, variant connect 4. So you're going to have a main method. You have to have a main method. One approach is I don't think it actually has a stipulation about this, but whatever the assignment says overrides this, because it's the official one. Public static void main, and so on. And as you write the code for connect 4, one approach is you would not instantiate an instance of a class that contains name, or you shouldn't. So with the assignment, the basic structure is static. It can return a type and return nothing. I'm just having a filler method here. Font. It's red by default because most of the time I'm just annotating stuff. Shrink the font. Oops, wrong one. So you have methods to implement the code for that variant. It's not the full connect 4, it's a little different. So it's not the connect 4 game. And if it's a static method in the same class, then you can just call it like that. If you're outside the class A1, and then we have another method. In order to call another class's method, you have to do what's here. You have to include the class name. Inside, just the class name. Outside, no class name, just the method, slip of the tongue here. Outside class name method. Unless there's stipulations, I think likely the requirements is you define it without additional classes, unless it specifies you have to. So what you're likely going to do is define these like this. Yes, they are method because they're inside a class definition, but in essence, why did I call this procedural programming? Call a spade a spade. This is procedural programming. You're directly calling methods, even though they're called methods, like they're functions, no objects intervening. So that's essentially your A1 and the application of methods. There's questions at this point. Hands raised? No. Now, oh, I'm over time. I'll just leave a quick note here. The teaching, I have taught where, so I'll keep the recording part here so you can see it later. People have had to leave. I have taught classes in 233 a long time ago where I taught static early on. There's advantages, but after teaching my own experience, I taught static until much later, 3/4 of the way through. The advantage of having static taught earlier is it's easier to learn the language. You can avoid OO for the most part and just use mechanisms like branches and loops. You can get started easier if you learn static. The disadvantage of it is if the instructor's not careful, the instructors open up a can of worms. That person has taught students how to code in Java without OO. The students may then backslide and write their programs all procedurally, unless the marking key says something specific, and they'll hammer you if you actually implement it this way. Students could basically not have any OO in the course, and that would be a disaster because you're supposed to learn OO. So there's pluses and minuses to having static. Also, Professor Hudson wanted you to be able to contrast in Java. Versus recap where I left off. Just one other thing. Static versus non-static method. This is a non-static method. How can you tell? Because we have to create an instance. And over here, I'm referring to non-static methods. You can't call it without an instance. Over here, on the other hand, math is filled with just static instances. So I don't create an instance. And rather than say calling the instance method, actually through the reference, I call it through the class. That's the difference in terms of use here, static, non-static. And in assignment 1, you can't implement it in an old-fashioned. I straight out asked Professor Hudson, the learning objective he wanted to have you apply was, what are things like procedural approach in Java, then contrast that with the OO approach. So specifically, you had to implement it with functions, procedures, which means static. Defining static method attributes. Well, some of this I had to jump ahead because he had all these peek aheads, and Java has that peek ahead with the public static main. This is an additional modifier putting between here, indicate whether it's static or not static. If it's left out, then it's non-static. In this case, static 1 per class, and you access it through a class. Leave it out, then the number that you have of this attribute depends on how many objects. It's an instance attribute. To access static methods attributes, when you are in the methods of the class, similar to the non-static ones, when I have the name, we just have the name of the attribute or the name of the method. If it's static, no different. You just put the name of the static attribute, just the name here. Little bit different if you're outside. And this part you should remember, outside the class, even in Python, when you actually created an object, you had to have a reference or an instance of that object to be able to access the attributes and methods. However, with static, recall, this is a static method. We access it through the class. Or with class person, this private, as we see, will stress more, means you can't access it outside the class. This is something that doesn't really exist. It isn't properly implemented in Python, so we need a method to be able to access this. That's where the get group size comes into play. But the key part is, if we can access it, it's class name dot method name. Now, to put this all together in an example, because we have different things here. This full static example. Oh, no. This one ends up being busted, and I'll just quickly go over to, procedural. I made a copy for some reason. I guess fooling around with stuff. And it's taking a while because it's importing it into IntelliJ, so it's creating all the files and all the other stuff. So you get the output, and we've got quite a bit of stuff happening here. So let me comment out at least this part here, 2 outputs. Show size is going to show size displays online the group size attribute here. So I'll only display one of them. Good grief, that was awfully slow here. All I did was comment out something. Okay, population 0. So at this point, we call this show size here. We haven't created any instances. Show size, the population, we display the group size. Group size right here, we typically shouldn't set attributes to values outside of the constructor. But the thing is right now, we haven't called the constructor because static attributes, again, as I've been stressing, they exist independent of any instances. We should be able to query the population or the group size before we create the instances. It's 0. So we set it to 0 even before we call the constructor. So we get the 0 right here. Then when we create the 3 here, well, we call the constructor 3 times, and in the constructor, even if it's a static attribute, we can directly access it. Group size, we increase. Now, this private, I'll stress further, means that we cannot access it outside these methods. If I change this, actually, before I change it and have a fair, do the questions of this at this point. Has a static attribute, that's a learning application, a static method. Okay. Now, the variation. If I change this to public, now it means that I have permissions to be able to access group size. Here. So, whoops, without the brackets here. And I could pass it to print out. That's not a good thing. So it needs to be private, and it's not a good thing. I'll stress in the next section here. It needs to be private so that we can only access here. In a way, it's kind of like scoping with local variables. So we don't want to be able to access it throughout the whole program. Fine. Since I just said that we can access group size, a static attribute, in a non-static method, you might ask yourself, well, these methods are public. Why couldn't I just write a non-static method to be able to display group size? So suppose I took out static right here. So this is evaluating. This isn't a participation quiz, obviously, but it's still evaluating your understanding of how things work. Try and work through this. Think about this. Why does that have to be static? That's my question. Or does it have to be static? Based on this example, there's enough here to figure this out. If you can answer why it has to be static, stick up your hand. Okay. I asked you the why part of it. Let's try the why not. If we didn't make it static, what would happen? Didn't make it static. As I just indicated, there may be a need to query the population, determine the size, the current value of the static at the very beginning. How would I do that now? Before I've created anything, I want to check to make sure that it's correct. Okay, let's try previously. I got rid of that. Let's try this previously. Person dot. Previously I had person dot show size. What would happen if I tried to do this to be able to display the population? I would call that. It's there. A hint, I have deleted the static keyword. It's making the world of difference here. Okay, well, right now I'm calling it as if calling because it's through the class. However, it is not static. I need to call through an instance. I should get a compile error at this point. I'm calling a non-static. It's going to say something to the effect, I believe, of non-static method as if it were static. Or the IE part. Review what I previously said. Non-static methods, you need to have a reference to an object to be able to call it. I could create an object here. And then call through that object, that would, and then delete, oops, delete this. Rid of that. And get rid of this. Then I'm calling it through an instance. No compile error. However, there's a problem. I've just introduced a logic error. I'm trying to check to see it's correct at the beginning. I've created an instance. It calls constructor. Now group size, it's been increased. So I'm going to get one instead of 0 when I don't want that. So mixing up the static and non-static is problematic. That's why I went through this example. They mix up the two. It's either static or non-static. It's mutually exclusive. However, in your assignment, give you a quick recap. If you, unless there's a stipulation explicitly against this, I haven't gone through it carefully enough to say, what you might do, this is only a part of it here, is make it all one class. This didn't really give me an answer, just give me an outline of how to approach this. Whoops, that should be static too. It might help to get around these. This should be static. Is if you are inside the methods of this class, connect 4, not 5, but connect 4. Yeah, connect 4, I think it was called. Then you don't actually need the class name. It's aware of it because it's inside the class name. All you need is a method name, whether it's static or not. That's another thing you don't have to worry about. Instances, instance name, class name. I'm not quite sure if it has a prohibition on it. I'd suspect probably not, since he's focused on static. If it was prohibition on just putting on one class, then comes non-static, you'd have to create another class. Final part in this section, final and static. Don't mix up these two. So I'm trying to clearly distinguish between static and non-static. I went through the basics first, then I went through the variation, and that variation is a mistake you all could make. Let's try and confuse you. Another thing to keep in mind is sometimes people mix these two up. To indicate that a memory location is a constant, unchanging in Java. It's not all that, not the same keyword in other languages. Final. Whatever you put there when you create that memory location, whether you initialize it or not, you can't change it. If you didn't initialize it, then it's a default value. Other languages, it's different. C++, it's C1ST, for instance. Static sounds like it's unchanging, but they made that choice meaning that it's class memory. And final and static, you can use these keywords, two keywords, interchange. You can use them in whatever combination you want. So there's 4 different combinations between final and static. Having neither, having both, having one or the other, and then flipping it. Oh, I shouldn't have used that word. Not interchangeably, but interoperably. That's the word I was looking for. Cross that one out. Used the wrong word here, thinking. I just about said it out loud, but then during presentation. I thought of another word, but you probably don't know that word. The other word is orthogonal, any combination. I took out orthogonal and sorted it because you don't know that word. I put interchangeable. That one doesn't mean the same thing. Can't use one place. So you got the static and final. So we got from all combinations, both of them to none of them. This is the one slightly screwy one. Static means class. Final means constant. So that means for that class, there's one memory location, not a memory location for each instance. And that memory location is unchangeable. That's all. Easy enough. The flip side here, we use neither. If it doesn't have static, it means it's an instance variable. It means that each instance has that memory location. And think about it, student ID, if this is for class student, of course, every student should have the ability to store their own student ID. There is no final keyword, so that means it's variable. This one, static but not final. Static means it's associated with the class. No final means it's variable. So we have one variable that we used it for population size, or we call it instance count, number of instances, objects we create, and we can change that as we should. So these three are the more straightforward ones. The last one's a little bit tougher. Final without static. Instance constant. Okay, why is it instance? Well, no static. That means each object will have this attribute. Final means it can't change. Now the question is, why bother? Is that just a snide comment I'm making, or is there something to it? Hint then. Why did I say why bother? Reason. Okay, work it through. What happens if we do this? We write our program. Okay, there's no static. It means that each time we create an instance, it'll have that memory location called cannot change. And that memory location is one for each object. So we create one object. We have a cannot change constant. We create another object. We have another cannot change object. We create I don't have enough. I have a third object. We have that cannot change the location. Can you see now the three objects? Why I said, why bother? Still can't see it? Well, another big hint. I have three objects. Each object has a constant. In other words, cannot change for this one is 1. Cannot change for this one is 1. Cannot change for this one is 1. That's a hint as to why bother. If we're storing the same information, and that information cannot change between these three objects, why are we storing it 3 bloody times? With the ID number, we have 2 different students. They're going to have 2 different ID numbers, or 2 employees, 2 workers have 2 different social insurance numbers. There's a reason why. But if we have 2 workers, and just say we had a flat income tax rate, everybody's taxed at 10%, would each worker object need to store the tax rate 10%? This guy stores 10%. It's a waste. So those instance constants are pointless. It is possible by the syntax, but it's the same information. Why bother with it? If we made it a class constant, each instance could still access it.